Okay, is it audible now? Okay, is it audible now? So, yeah, welcome to this course on pattern recognition and application. So, specifically, uh, this is offered as elective for your fourth year. So, uh, actually, we will work out on the mode of teaching, that is the platform for teaching online. So, today, since your mid-exam is nearby and we need to cover up some quick topics, I use this YouTube platform. We may not interact in real time, but I think it has some 10 seconds of latency. However, you can just post your doubts if you have any in the YouTube chat list. I will be tracking that. And I will ask the management to uh, activate that Microsoft Teams maybe after mid, okay, or as soon as possible. So think you can see the screen. So going into the topic, uh, first we'll see the syllabus initially. So you have 6 units. You know the structure. So the first unit deals with the fundamentals required for this course. Uh, we have polynomial curve fitting, which is the basic step towards pattern recognition, and we see the curves of dimensionality, decision theory, information theory, all these basics. Like they are like uh, divided in parts, but all together forms a good foundation to learn the advanced next topics. So basically, the first unit completely deals with the foundation concepts required for understanding of pattern recognition methods. So the second unit we enter into the first category of pattern recognition, that is regression, and next we go for the second one, that is classification. So we see what is regression, what is classification, what are the differences, and how to implement regression classification. And we see some consequences of data, the effect of data on these models, regression and classification models. And then we see the probabilistic approach of this regression and classification, that is Bayesian and linear regression. There are two ways of looking into pattern recognition problem. One is mathematically uh, two ways. One is based on the linear algebraic perspective, and the other one is the probabilistic perspective. We see that, and the principal component analysis, probabilistic generative models, and discriminative models. Okay, these things cover in the second unit, and the third one are the kernel methods. So here Okay, this is relevant to more like linear algebra. So where we uh, see how the projection of data into a space where it can be classified much better. Okay, so yeah, we'll give a more uh, deeper understanding of this, and in the next sessions. And primarily, we look into two major areas of pattern recognition. One is the statistical modeling, and another one is the neural network based modeling. So, in the statistic unit 4 deals with the statistical modeling. Here we have GMNs, like mixture of Gaussian mixture models, and then for modeling the data which does not have any temporal sequence information. For modeling the temporal information, we use hidden Markov models. And linear dynamical systems, like we have Kalman filter or something like that. And in the fifth unit, it is completely about the basic understanding of neural networks, how they work, okay, how they are trained. Okay. And finally, there are application topic, which is speech recognition and character and handwriting recognition. So speech recognition is uh, a one-dimensional signal processing problem, whereas character or handwritten recognition is a two-dimensional signal processing problem. And then we have uh, analysis of biological sequences like ECG, EEG, or whatever. Those are, so if time permits, we'll see that application as well. So that is our syllabus. The and Coming to the references, okay, uh, you have Christopher Bishop. The entire syllabus is taken from this book, Pattern Recognition and Machine Learning by Christopher Bishop, Pattern Recognition and Machine Learning. Okay, you can follow this uh, textbook for all information related to the syllabus. And coming to the video content, you can search for any NPTEL videos. So there is one NPTEL video by IIT Madras. Anyway, I think uh, the syllabus is different. I think according to the syllabus, I don't find, but by parts. So for each and every unit, I will be sharing the video links later, unit wise. Okay. So are you all following? Yeah, as I said, you can type in the chat box so that I will I will get to know. Okay. So right, we'll start with the definition of pattern. Before that, I will give few examples of what is pattern recognition. Like in the sixth unit, you can see we have speech recognition. Okay, face recognition, like digit recognition or character recognition, handwritten character recognition. So all these are the pattern recognition applications. So what is a pattern basically? So pattern, for example, if you want to identify or register your friend's face in your brain, okay, so that you need to identify him regularly. So you will make note of some distinct features like the eyebrows, okay, color of eyeball, then the nose, chin, and the face, whether it is round, overall face shape, whether it is rounded, oval, or something like that. Okay, so all these characteristics together, okay, are helpful to identify the person's face. Okay, so they, since it is a two-dimensional thing, for example, if I draw a face something like here, the person is having some circular shape of his face, and the eyebrows maybe something like this. So if you want to remember this face, we'll get some suitable characteristics, okay, and we'll try to map those characteristics with each other. So here we refer mapping. So mapping means we, most of the again it is a philosophy that our brain remember the things by mapping, not by storing. Okay, you know the difference between the storing and mapping with the, or knowledge mapping. Roughly saying, storing means whatever the data you have as it is, we need to store without any changes or some like your storage devices or computers or smartphones stores the images uh, by pixel values. Okay, pixel by pixel, you have, for example, 20 cross 20 image. This 400 pixel values, it will store in a memory location, and whenever that image is given, the same copy of the image is given, then it will say that okay, this image is there with me and it is there in this location. Okay, if you do some image search kind of thing. Okay. But if the slight difference of this image, like you have removed some portion or you have added something extra to the image, and then give to your smartphone that do you know this image, then the smartphone is just storing the data. So it says that okay, I don't have this data in my database. This is something new. I don't know this person like that. Yeah. Okay, it will, okay. That is storing, just storing the information as it is, and there is no kind, there is nothing like processing or something like that. In the knowledge mapping, okay, here you have seen many persons, okay, eyes, nose, eyebrows, everything. So if you meet a new person, you try to correlate, but you maybe know, you may or you may not know, but you feel that okay, I have seen this kind of face earlier sometimes. Okay, so you try to correlate that person's face with your one of the faces existing in your brain database, and then you, that's how you try to remember that. Okay, for example, there is one cow and a sheep. Okay, how do you differentiate between cow and sheep? Okay, because the sheep characteristics are different from cow. Okay, so one thing is uh, Let us take weight. So obviously cow has more weight than sheep. Okay, here W1 will be less than W2. Height, okay, and here also the height of the sheep is less than the height of the cow. Okay, and the distinct characteristics like horns. The sheep horns sometimes are it has those horns also. Okay, length of the horns like L1, L2. So cow has more longer horns than the sheep. Horns means like we say komulu. Okay, that is. So when you try to differentiate between sheep and cow, so what you do is just to find the length, weight of the sheep, weight of that animal. For example, a new animal has come to you, and someone asks you to identify which animal it is among sheep and cow. So you take, for example, if you plot this data on the x-axis and y-axis, like for example, weight is on x-axis, uh, and height is on the y-axis. So these are the two-dimensional. This forms a two-dimensional space now. Okay, whose one axis is weight and another axis is height. So if you take all the weight height combinations of different sheep, okay, they all fall at one location. Okay, these are like 20 sheep you have taken. For each sheep you have found this pair W comma H, what is the weight of the sheep and height of the sheep, and then you have just plotted this W comma H as a point in this two-dimensional space. Then again you take cows, 10 cows or 20 cows, and then again take the weights and heights of the cows as a ordered pair, and then uh, if you mark that order pair or two-dimensional points on this space, since they have more weight and more height, they lie slightly above the these points. Okay. Okay, now you can discriminate here. Okay, easily you can discriminate with the height and weight. Okay, see all the cows are falling at one point, all the sheep are falling at the another point. So you can just have a boundary between these two groups. Okay, this you can just boundary means a line separating these two. For example, we have every country has boundary, every district state has boundary. Likewise, these two classes have some boundary. Okay, if you cross this boundary, you will enter another group, like another state or another country. Here also, if a point crosses this boundary from one place to another place, then it falls in the one group. If it lie below this boundary, it falls on the. So all these belong to the class called sheep. All these points belong to the class called sheep, and all these points belong to a class called cow. Okay. So any new animal comes, find the height and weight, and see whether that point is lying above this line or below this line. You know how to. That is simple mathematics. Like you substitute that point in this line. If that resultant value is greater than zero, that is above the line. If the resultant value is less than zero, then the below line. If the resultant value is exactly zero, those points are like non-discriminative. We cannot find exactly on the line. Therefore, there are some methods to solve that we'll see later. So this is how we classify. This is called classification problem. So what we do here is we'll see that more clearly later. What is classification? What we do here? What is our data? We collected some data. Okay, we collected some data, and what kind of data you have collected is important. Not that collect each and everything. For example, the color of the, if you have taken the color as one parameter, so you may find white sheep and white cows. Okay, there is no such difference. Okay, and if you have taken the for example eyeball radius, I don't know, but still I feel that sheep and cow, almost some sheep may have the eyeball radius as same as the cow. Okay, that is not going to work out. Okay, so there are some parameters which reflect certain patterns. Okay, there are some parameters which reflect some patterns that are specific to a object. Okay, given object. Okay, those parameters are discriminative with respect to given set of objects. So, so those parameters we need to, or those factors we need to selectively choose. Okay, so but in this example, okay, you have everything is there. Okay, cow, sheep, everything we have day to day life. We have seen many. You can find. But for example, for speech recognition, let us say speech recognition or speaker recognition, whatever it is. So you hear it, but for example, if you see the wave file, okay, all the waveforms, because speech is a random process. Random process means when you vary time, you cannot predict the outcome. Okay, the outcome with respect to time is highly random. Okay, so in the time domain, particularly, you cannot find any uh, discrimination or pattern in speech. Okay, although at minute level, for example, if you take vowel versus another stop consonant or something like that, so some things you can have some difference, but vowel, one vowel versus another vowel, if you see the speech sound, if you plot the waveforms of speech collected from a microphone, then you can't find any difference. Okay, you cannot understand the speech signal as such. And then ECG signal is much more, uh, uh, though it looks like a deterministic, but there are a lot of parameters involved in it. Like this, this is called a PQRS peak will be there. This one set of pulse you take, this pulse and this pulse looks exactly same, but this width of the pulse changes. Uh, that you need to extract it from the ECG signal by doing some signal processing. Okay, by just looking at the time domain signal, you cannot identify. So in like speech also, you cannot identify by just observing the waveforms. Okay, you need to either go into the some do some signal processing, get some like this. Okay, get some frequency domain transformations and like that. So in this data, this is data in time domain, some domain, but the pattern is hidden here. Okay, uh, the pattern is there because you are still able to identify. For example, this is person one speech, person two speech. If you hear these two waveforms, you are saying that okay, this person is different, this person is different. If you hear, perceive it. But if you see in the on a screen, if you plot these waveforms and see on the screen, so you may not able to differentiate uh, whether though given two waveforms belong to two different speakers or a single speaker. You may not, no one can identify. Okay, that is very very difficult. Almost impossible, I can say. So, but the information is there, okay, in the waveforms, which depicts two different persons. So we need to find a way to extract that, okay, information, and then process that information in order to identify the two different speakers. Okay, so this process, okay, this process of once we have the data, we need to extract some suitable information and then process it to give some decision about the data. This whole process is pattern recognition. So from the data we need to extract some features, discriminative features or whatever it is. So we need the data is of very raw form. Okay, raw data don't have any patterns visible as such or perceivable as such. Okay, but When for a computer, and we are talking about data means, okay. So before that, I'll just define data and pattern. Data versus pattern. Human, okay, human beings sense everything as a pattern, whereas machines only knows data. Machines don't know patterns. Okay, this is the definition or discrimination between the pattern and data. Human does not have any thing such kind, like if you hear some voice, if you see some scene, everything you can understand the pattern, even though it appears as like you won't see. For example, if you are watching at a movie, you won't see this is the frame rate like 30 frames per second. In 15th frame, 20th pixel value is red. You cannot see like that. Okay, you just see some fellow is running, some song is coming, some music is coming, something like that. You see, perceive everything. You process, the brain process the patterns. Okay, but machine processes the data. Machine don't know what is pattern or is just the machine knows only numbers. Okay, machine knows when a movie clip is given to the machine. Machine sees that movie clip as like, okay, this is the frame rate, and in this frame, the 50th pixel is having black. Okay, like that. So that is the difference between the data and pattern. So if you can map or if you can extract patterns out of data, okay, that is what machine needs now. Okay, so that is machine. Then the machine that algorithm is said to be a machine learning algorithm. Okay, so you need to extract patterns from the data, and then using that pattern, okay, we do the top level task like classification or regression. So that pattern extraction, okay, or recognizing pattern in the data is called pattern recognition. That is the definition of the course. Okay, so and then we have, okay, many models that can extract pattern from the data. Okay, statistical math models and the neural network models and all these things that we'll see. The entire next thing is about how do we do pattern recognition so that machine can perform this pattern recognition tasks like recognizing speech, face recognition, or estimating or predicting the climate, all these things. So with this definition, okay, so we need some fundamentals to proceed, fundamental concepts to refresh. So one is curve fitting. So what is curve fitting? So in general, it is polynomial curve fitting. We have more non-linearities in the data. So in the curve fitting, you are given with some points like this, and you need to. These are discrete points. I'm just giving one example. This curve fitting, one-dimensional curve fitting. I'm giving example. So you have the x and y, x comma y points. Some discrete instance of the points are given. So now you need to fill the gap between these discrete places. That means you need to find a curve which passes through these points. Okay, exactly passes through the points or approximate curve which can pass through this points. Okay, so this is called curve fitting. So we are fitting a curve that exactly matches with the given data. Okay, so for example, you are given with 0 x and y points are given like this, 0 and 0, pi by 4 is root 2, 1 by root 2, okay, pi by 2 is 1, 3 pi by 4 is pi by 6 is pi by 3 is by 6, okay, pi by 6 is 1 by 2, pi by 3 is root 3 by 2, and so on like this, pi is 0. So, okay, you know this because you say it is a sinusoid, but system don't know that. Okay, so you have x coordinates and the corresponding y coordinates like this. Okay, one half cycle of the sinusoid. So then you need to do some curve fitting so that it will reconstruct the sinusoid curve from the given small data points, the small set of data points. So which is often uh, because which is there is no straightforward method to do this, okay, because all we want is to find a curve that passes through this point. There may be multiple curves passing through these points, maybe like this, okay, or even higher order if you go. So there may be multiple curves that can pass through, but we need to know which is the most suitable curve. Okay? But the problem of curve fitting says that just we need to fit a curve to the given points. We'll see what is linear regression later. This is the extended problem of curve fitting, but we can't rely on whatever the number of curves that passing through. We need to choose only some such curves that suits exactly to the given data. So how do you do this curve fitting? This is a basic mathematics problem where you have the x and y coordinates and you need to find a continuous function that passes through, like we need to find y equal to f of x. This is the fundamental problem. Okay, y, what is the relation between x and y? X is the x-axis, y is the y-axis. Okay, that is the thing here. What is the relation between x and y, and how do you approximate it? Some mathematical equation. Y can be a constant. Okay, y can be a linear function like mx plus c. Y can be a second order polynomial or ax square plus bx plus c. Y can be third order polynomial, nth order polynomial. Okay, an x power n, an minus 1 x power n minus 1, and so on, like up to a naught. Okay, we don't know. Okay, so we don't know what curve fits better. But for that we need to do some analysis. We will see it later. Okay. So all that we need to do is we need to find if it is a y, if you are approximating this x and y relation as y is a constant, there is no meaning. Okay, we can just simply avoid this. Okay. If y is not changing with x, then it is a, then you can consider, otherwise. Okay, if there is a linear relation between y and x, okay, y equal to mx plus c, whether it is having a positive slope or negative slope. Okay, based on that, you can find m and x because you have multiple points. Okay, you can find m and x. And also, if you can still go for this higher order polynomials, and you can find the constants, corresponding constants for the given set of points. Okay, so in this way, you can do curve fitting. Okay, so we format the problem like this. Okay, the problem statement of curve fitting, I am just giving problem statement. given set of points xi comma yi, I is equal to 1 to n. Some n points are given to you. Okay. From this, you need to find a function of order of given order. So the order is, let us say, for now it is given. Okay. Or for any order, you need to find a function. Okay. So for you need to find a function of a given order such that f of x minus y or f of xi minus yi. Okay, squared error. This is called error. Ya is your true label. That means for a given xi, ya is the point given to you. Okay, and f of xi is the function that you have are assuming. Okay, or you are formulating for a given order. Okay, so then take the error and sum the errors for all the given points I equal to 1 to n. This you call it as j, and this j has to be minimum. Okay, so then if the error it has to be 0, that is fine. If it is minimum also, we will try to estimate the function that gives minimum error. Okay, so how to find this f? Because f is nothing but it's having a formulation given on the order, like as I said, like a, for example, ax square plus bx plus c. So you need to find a, this here unknowns are a b c. So this f represents this ABC represents this f. Okay, so we need to minimize. You need to find a comma b comma c such that the most suitable values of ABC such that this j should go to 0 or minimum. Okay, so that ABC values you find by optimization. Yeah. So you find the ABC values and then you try to then you get f of x, then you can this f function, it's a continuous function, then you can find the y for any unknown x. Okay, so that is curve fitting problem statement. The solution we'll discuss later. Okay, so this is the problem setting. You have some given set of points, you need to find a function of given order such that this error should be minimum. Okay, so this function means it is associated with some unknown parameters. You need to find those unknown parameters ABCs such that the overall error goes to minimum. Okay, so okay, so do you have anything to ask? You can put in the chat box. So so now we have the curse of dimensionality. So what is curse of dimensionality? So, as we said in the earlier example of sheep versus cow, so we have taken two dimensions, which is weight as one coordinate and height as another coordinate. Okay, our data point x here is two dimensional, 2 cross 1 vector, which is w and h. With this, okay, we felt it is sufficient to classify sheep versus cow. So we said if we include any other parameters, okay, like apart from weight and height, like color of the sheep, okay, and maybe eyeball radius, radius of eyeballs, all something else, okay. So these are not so useful in discrimination, okay, because these are common things among the two classes. These are like same color sheet may be there, cow will be there, like that. So if you try to put this onto a, okay, this is four dimensional. So uh, we can, I mean not, you can draw four dimensional space. Okay. So just assume, okay, I'm projecting it to two dimension. This four dimensional point, when we project into two dimensional space, then there will be an overlap between cows and sheep. Okay, they are not as differentiable as the two-dimensional case which we have seen with respect to weight and height. When you include some other parameters, some other features or some other attributes of the data, then earlier they are discriminative. Now they are not so discriminative. There is overlap. You cannot draw any line that can differentiate these two circles. Okay, so then the classification becomes difficult. Not difficult. It is in the class. The lot of errors will be there. Many points will get misclassified. Okay, so these extra dimensions are not helping us. Okay, that is curse of dimensionality. Okay, if you feel that, for example, if you have an image, 20 cross 20 image, that means 400 points, okay, 400 values. All those 400 values you put as a vector, which is 400 cross 1 vector. So this is a now 400, this is a one image, x image x1, let us say. Likewise x2 is another image of, this is like a image of a tree, another tree will be there. This is like a that is like a neem tree. This is like a coconut tree. So if you want to differentiate between neem tree and coconut tree, you need to take the images of all those trees. Okay, each image is of 20 cross 20, so 400 dimensions will be there. So 400 in the 400 dimensional space. Okay, if you uh, project this trees into a 400 dimensional space, there may be lot of overlap. Okay, because all the 400 points does not contribute to the features of this or pattern of this tree. Okay, there is lot of background. The tree is only some small portion of this image. Okay, lot of background will be there. Okay, and there are some similar portions are common between these two trees. Okay, like some portions of the stem is same as some portions of the stem of neem tree. So all these things will be there. So we need to, if you take more and more dimensions or more and more data or complete raw data as it is, then it is difficult for a machine to understand, okay, to discriminate. Okay, so that is curse of dimensionality. You feel that the more data is there, it is very easy to understand, but it is not like that. Okay, so if you should have sufficient amount of data, but it should not have, okay, uh, all the like what we say, what we call mm, what is the word? Okay, so extra all the data which is not contributing anything to this. Okay, so this is curse of dimensionality. Okay, and it is also, on the other hand, it is also same as saying two less number of features are also not, two less number of attribute is also not. good, you need to have sufficient, neither too less or not too large. Most should they need to extract such information, information in some dimensional space, such that they are most discriminative. Okay, so two less dimension. Okay, this is a, for example, dimension scale. Okay, 0, 1, 2, so on. This is like very large dimension n. So two less dimensional, here also it is very difficult to classify, like one dimensional, two dimensional data. Here also like 1000 dimension data, 2000 dimension data. Here also it is very difficult to classify. But here something like 10 dimensional, 20 dimensional may be useful. Okay. So this is for example, for the speech I am saying. Okay, speech. If you take one-dimensional vector or two-dimensional vectors or features, it is not going to work. Or even 1500 dimensional or 2000 dimensional data also is too high. All the wave samples, if you take together, it is also very too high. So you need to extract some information in a suitable dimension space, like 10 or 20 dimension. That is fine. Uh, that will work in general. Okay. So, did you understand the concept of cuts of dimensionality? You should not have too many data dimensions in the data, so because they may be misleading. Okay. So, yeah, information. So now you see the few concepts of information theory. So, what is information? Is something, some knowledge that we have about certain thing. Okay. So, and the corresponding term to the information is uncertainty. So, this uncertainty tells us how much information we have. Okay. For example, if you are asked to tell, okay, whether it is going to rain tomorrow or not, okay, you are not so certain about it. Okay. But if you are asked to say, if you eat, for example, is biryani your favorite food? Then what you say? Certainly, you say some decision, because you know, because you have already tasted it. You like or dislike. You just express that thing. Okay. So if you have the much of the information, then you get certain decisions. Okay, you can, if you know much information, your decision is clear. Okay, you can make out decisions. If you don't have much information, you cannot take any decision. Okay, in these cases, you can go for some confidence level. Okay, with how much confidence you can say, if you say you don't know, for example, you don't know whether it is going to rain tomorrow or not. But if you ask again, with how much confidence you say tomorrow it is going to rain, based on your observation, last 2 days data and today's weather conditions, so you can say that okay, tomorrow it may rain by uh, like I have 20% confidence that it won't rain tomorrow, and 80% confidence that it will rain tomorrow. Okay, so this we call it as probabilities. The probability that it is going to rain tomorrow with respect to your decision. Okay, probability of it is going to rain tomorrow, and probability it is not going to rain tomorrow is zero point 0.8. Okay, this is zero point 0.2. This is zero point 0.8. So the information is related to probability in a sense. Okay, we formulate what is the relation between the information and the probability. So the mathematical equation says that if you have more information, your decision is certain. That means with 100% confidence, you will say that okay, I like biryani or I don't like biryani. So for that, the probability is one. Okay, probability always go to one. Okay, so yeah, so this is extreme case I am talking. So if you have more information, you have your confidence in giving the answer is more. Okay, if you have less information, then your confidence will be less. Okay, so that means probability will be more, and the probability will be less. So this information, amount of information, is measured as. See, this is a topic raised from the communications generally. Information content, okay, is uh, or self information. They call self information is defined as log of the probability of making that decision. Okay, and entropy is defined as they gave another more meaningful definition for the how much information you have, that is called entropy, is defined as sum over you have many variables to express. Okay, whether rain or not rain are two conditions. If you say tomorrow which color dress are you going to wear, okay, you have multiple options, red, green, blue. Okay, those are all called some uh, conditions or symbols. So I is equal to 1 to n. If you have, for example, the n conditions, pi log 1 by pi. Okay, this is the entropy where log is with respect to base 2, because in communications our decisions are binary. When the symbols are binary, 1 0 or 1. So so this is called entropy. Okay, pi log a or minus I is equal to 1 to n a log a. So actually, if you extend this to the concept of random variable, because everything which you don't know, if you are not certain, you can model it as a random variable. Okay, so deciding tomorrow it is going to weather condition is a random variable. Here in this example, the weather condition is a random variable, and it takes 0 or 1, that is secondary. What values it takes is based on the how do you define the random variable. Okay, so this random variable, as soon as we say random variable, and by from your basic probability theory, you should know that every random variable has a distribution. So in this case, it is a discrete random variable because the outcomes are discrete, 0 and 1, whether yes or no kind of thing. So discrete random variable is in this case we take, and the measure of the discrete random variable, the characteristic of a discrete random variable is given by its probability mass function or density function. It has some distribution and or probability mass function. So, and that is p of x is equal to I, or in general we call it as pi. Okay. So these probabilities indicate the distribution of the given random variable or entropy of the random variable. You can also call this as the entropy of the random variable is given by, if you know the distribution, you can calculate the entropy. Okay, that's the point I want to convey. Okay, so if you know the probability distribution, you can compute the entropy. So what is entropy? That is the measure of information. Okay, if you know the probability distribution, you can measure, okay, the information content present in that. And uh, now we'll, like that we'll define cross entropy. The cross entropy is between the two random variables x and y. Okay, so what is the x is having one distribution px and y is having another distribution py. Okay, so cross entropy is defined as a minus uh, px log py. And you also have mutual information. So here the, okay, I will say x and y has few common samples pi px, okay, core x or O. Okay, I will just give you more clear. I is equal to 1 to n. Let us say you have n symbols. Probability of x taking I and log of probability of y taking I. Well, that is cross entropy. And so, and we have mutual information which says the common information across two random variables I x comma y is defined as x of x is equal to I log, not this minus p of x is equal to I by p of y equal to I. Okay, so you revise this information theory concept. This I might have covered in the communications. Okay, so we will stop at this point. Okay, I will share this content also, and tomorrow also we'll meet and we'll discuss the remaining portion of the unit one. Okay, so if you have any doubts, you can just send a message or, okay, WhatsApp or mail to me. Okay, I can answer. Okay, so stop at this point. We'll meet tomorrow. Thank you.